For decades, classical psychology has relied on a straightforward assumption about human development. It suggests a linear progression. External events shape memory, those memories shape personality, and that personality dictates all future decisions. While that framework explains a lot of behavior, it leaves a critical question unanswered. Continuity theory and the Brain Kinematics Model propose a different mechanism. In this framework, memory operates as an active, prospective constructor. Experiences merely provide the raw informational and emotional material entering the nervous system. They are only one fraction of a much larger regulatory cycle. This continuous loop is driven by three primary forces: environmental experiences, sleep-mediated reorganization, and intrinsic mental capacities. These three forces operate recursively. The environment influences sleep, sleep edits cognition, and that changed cognition dictates how you interact with tomorrow's environment. The trajectory of human life is governed by the continuous construction of adaptive models for the future, rather than archived events of the past. To understand how this works, we start with the first regulator, environmental experience. This is the mechanism that injects sensory data, cultural knowledge, and emotional perturbations into the brain. In this framework, emotions are treated as quantifiable regulatory vectors. They act as physical forces that direct the flow of information through cortical pathways. This phase space graph tracks cognitive state over time to illustrate how those vectors operate. Positive emotional states increase the probability of approach behaviors, pushing the system in one direction. Negative states trigger defensive and avoidance routing, pulling it back. Over short timescales, daily cognition oscillates heavily between these complementary emotional poles, like hope and fear, or trust and distrust. These short-term fluctuations generate the behavioral variability you see in daily decision-making. But notice the central line. This is the homeostatic balance axis, the stable anchor that all these countless rapid cognitive oscillations orbit around over weeks, months, or years. Positive feedback amplifies a direction temporarily, while negative feedback gradually pulls the system back toward this center line, keeping the brain from spiraling into total cognitive chaos. Reasoning and logic do not exist in a vacuum outside of this system. Advanced cognition develops directly on top of this continuously changing emotional landscape. While minor events cause temporary ripples, highly significant life experiences can permanently shift the angle of the homeostatic axis itself, establishing an entirely new equilibrium. Your daily cognitive path is the mathematical average of millions of interacting emotional adjustments, continuously oscillating around a stable, long-term regulatory line. Moving from abstract behavioral graphs to the literal mechanics of the cortex reveals how this stability is physically maintained. According to the Brain Kinematics Model, every waking experience generates new, localized strain fields within the brain's physical network. These temporary spikes in strain potential force information to detour and flow along specific, highly active cortical pathways. This animation shows sleep and dreaming acting as the brain's second regulator. Their primary mechanical function is to resolve those intense localized pressures. Deep non-REM sleep sweeps across the network to stabilize the cortex. It mechanically consolidates the most useful memory traces while weakening and pruning irrelevant connections. Then, during REM sleep, the process shifts. The network begins firing erratically, chaotically redistributing that daytime strain across distant, previously unconnected regions of the cortex. As this redistribution happens night after night, some strain marks merge. Some disappear entirely. Others synchronize to forge entirely new organizational structures. Dreaming represents the visible, conscious manifestation of the brain constructively testing novel combinations of redistributed strain. There is a severe asymmetry here. The environment only dictates the raw data that enters the system. Sleep dictates what survives, and exactly how it will alter your future architecture. Experience writes the first draft. Sleep edits the manuscript. Without sleep's continuous, mechanical redistribution of cortical strain, environmental input simply cannot be converted into a stable cognitive framework. If sleep breaks down and recombines our daily memories, what is the final long-term product of all this consolidation? The long-term result is the formation of emergent regulatory structures. These are worldviews, conceptual frameworks, and ethical systems that outlast the isolated memories that formed them. Imagine a child who experiences hundreds of individual, isolated acts of kindness over several years. Those distinct episodes are integrated overnight, repeatedly, until the memory of the specific events fades away. What is left behind is a massive, central abstraction. He constructed a novel, perspective model by recombining acquired components in his mind. Charles Darwin did not directly observe millions of years of evolution. He synthesized countless disconnected field observations into a single dominant guiding framework. This is the perspective function of memory, the continuous generation of increasingly adaptive models for navigating the future. Ultimately, these constructed mental models, which have never existed in direct experience, become stronger drivers of your life than the actual memories from which they emerged. This brings us to a critical variable. Why do two individuals subjected to the exact same experiences, with the exact same sleep quality, develop vastly different conceptual structures? The difference lies in the third regulator, intrinsic mental capacity. This equation illustrates the full system. Mental capacity includes biological limits on attentional control, working memory, cognitive flexibility, and associative richness. It acts as a strict mathematical multiplier. It determines both the raw efficiency of initial encoding during the day and the depth of abstraction the brain can achieve overnight. Development is driven by the recursive, compounding product of nature and nurture interacting over time. Because of this, identical inputs yield divergent life paths, dictated by the physical limits of each brain's internal reconstruction engine. Expanded across decades, the true architecture of memory is revealed. Cognitive maturation and wisdom are characterized by the successful dampening of emotional oscillations. Over decades, the evolving homeostatic axis is guided steadily by the gravity of emergent regulatory structures constructed over a lifetime. This leads to a stark prediction. Chronic sleep disruption will physically stunt the brain's ability to form coherent, future-oriented conceptual frameworks. The ultimate realization of the Brain Kinematics Model is that we navigate reality using continuously evolving models of tomorrow. Remembering what was and imagining what will be represent two phases of the exact same lifelong adaptive process.